Good afternoon, everyone. I'm Zhiyu, a graduate student in China. I'm glad to give a report at this meeting. My topic is pervasive programming online sharing charge pie scheming with different needs matching. The main research program is about how to protect users' privacy on the public platform and effectively complete the users matching. The outline of my talk as follows. I will introduce it in 4 parts. The first part, I want to introduce the background of this research and objective. The second part introduce my proposed scheming. The third part covers the data used in this research, and then we introduce in the empirical research. Finally, a simple conclusion is given. Part 1 is introduction. With the increasing number of electric vehicles, the demand for charging pie is increasing, but the popularity and coverage of charging pies cannot meet the demand. In the figure, especially the number of private charging pie has increased from 8,000 in 2015 to 874,000 in 2020. However, compared with the growth rate of electric vehicles, the number of charging pies is still far from enough. So far, those electric vehicle users who cannot install charging pies, the problem of charging difficulties become more and more obvious. The number of public charging pies is limited, but private charging pies can be shared in their spare time, and the owners can also get some compensation. The traditional charging pie sharing scheme is generally composed of 3 entities, including charging pie providers, electrical vehicles, and matching service. As shown in this figure, in traditional charging pie sharing scheme, the user's information is public or uploaded to the server through simple encryption, and the server needs to decrypt the participants' information to get their planned test information. So in the traditional scheme, the user's privacy may be attacked and leaked. In the traditional charging pie sharing system, all the information will be published directly on the internet. The goal of private charging pie users to show their charging pies when they are idle, and most of them are unwilling to disclose their private information for charging pies users. If a malicious user has used a charging pie and marked and recorded its location, he may use it directly without the platform when he knows that the charging pie has not been managed for a period of time. And there is also the possibility of exposing customers' privacy through the sharing service platform. For buyers of electrical vehicles, because the location information of electrical vehicles may include a workplace, home address, special hospitals, or entertainment place frequently by them. The information of buyers' hobbies and health status is leaked. Moreover, once the information of buyers and sellers is obtained by malicious attackers, not only will they be profitable and targeted advertising, but also the relevant workplace and home address will be attacked. There are three objectives. The first is protect users' privacy in the matching process, because the public platform is not secure in the traditional matching scheming. The second is more efficient matching in the encryption and decryption process. This is a problem that every matching system needs to consider. The third is provide the function to meet the needs of users in the matching scheming. We consider that different users have different needs, so we designed this function for users with different performance. Part 2 is method. My proposal consists of 5 entities: electrical vehicle buyer, charge pile seller, proxy server, cloud server, and CA. All entities communicate through the mobile network. In the scheme, buyers of electrical vehicles and sellers of charging piles send matching requests to CA. CA will generate the key, send the public key to the user, and send the private key to the cloud server. The user encrypts the data to be uploaded with the public key as a terminal and sends it to the proxy server. The proxy server has certain computing power, processes the cipher text state of buyers and sellers by homomorphism, and sends the process date to the cloud server. The cloud server uses the private key sent by CA to decrypt and obtain the process plant test date. The match according to the date and the needs of users to get the most suitable matching users. Finally, return all the matching results to the user and start the next round of matching. Paillier crypto system is a kind of partially homomorphic encryption with semantic security. The encryption scheme adopts Paillier scheme, which means the standard semantic security of encryption scheme, and has homomorphic characteristics. The operation on self-test is equivalent to operation on plain text, and the information about plain text will not be leaked in the cipher test. This scheme has homomorphism of addition and subtraction. In Paillier crypto system, the main cause of decryption is exponentiation in the mod square of n module. With the private key P and Q, the module exponentiation and mod square of n can be converted into mod square of P and mod square of Q by CRT. which improves the decryption efficiency. This is a mathematical principle of use CRT in parallel scheming. Parameter optimization is to make a Q equal n plus 1. And according to binomial theorem, redundant terms can be eliminated. The final encryption and decryption process is shown above formula. I stands for bias, J stands for seller, and W stands for user demand. The smaller the final value, the more suitable it is. And part 3 is the results. As can be seen from the left figure, the decryption time is about 1/3 of that of Paillier encryption scheming after accelerated calculation by CRT. And the decryption time of DJ scheming is basically the same as that of Paillier scheming. Therefore, using CRT to speed up the decryption process can effectively improve efficiency. Compared with the original Paillier encryption algorithm, the encryption scheming with parameter optimization simplifies the modular explanation operation into modular multiplication, which speeds up the encryption process. When attacker attacks a proxy server, the data in the proxy server is uploaded by the user after encryption, and the attacker cannot decrypt the data after obtaining it. So it is safe in this case. And when an attacker attacks a cloud server, the data in the cloud server is processed by the proxy server with homomorphism, so the attacker cannot get the valid state such as the user's location. Therefore, is conclusion. We solve the security problem of shared charging pie scheming through homomorphic encryption technology. We have formulated a privacy protection shared charging pie scheming based on users with different needs. First of all, we use the publicly to encrypt the information in the terminal equipment of the IoT, which efficiently protects the privacy information such as locations. Through homomorphism, the ciphertext matching the user is calculated in the proxy server, and the CRT is used in the cloud server to accelerate the encryption process. We design the matching rules, calculate the matching index, and compare them to get the most suitable matching results. When we return the results, we use parallel scheming with optimizing parameters to effectively speed up the encryption process. Finally, our numerical assistant analysis results show that the decryption time is shorter after CRT optimization. The time after parameter optimization is less, and at the same time, We also analyze the security of the system, which is safe and reliable on the public platform. Thank you.